I welcome all of you to the next session of Exploring Physics. So, in the last Zoom class, we have covered some topics in the third lesson, right? So, we will continue the third lesson called Force and Motion. In this lesson called Force and Pressure, we have completed these topics. We have learnt about force, turning effect of force. We have also learnt about pressure, applications of pressure, that is low pressure and high pressure. In today's class, we are going to study about liquid pressure, that is pressure exerted by the liquids. Do you know the name of the instrument to measure pressure? Manometer is an instrument used to measure and indicate pressure. This is the picture of YouTube manometer. This is an analog device. Nowadays, digital devices are available to measure pressure of liquids and gases. In today's class, we will be focusing on the characteristics of liquid pressure. We will learn the characteristics using various activities, so it's going to be an interesting session. Keep listening. We all know that solids have definite shape, but liquids do not have definite shape. So, they acquire the shape of the vessel in which they are kept. Right. Let us divide this water bottle into various layers. How will be the pressure in various layers? There will be low pressure at the top of the layer. Why I am saying like this? It's because each layer of water holds the weight of its top layer. See, each layer of water is holding the weight of its top layer. Then what will happen? The pressure experienced by the bottom layer will be higher than the top layer, right? That's why we say there is high pressure on the bottom of the liquid and low pressure on the top of the liquid. So the first characteristic is pressure increases with increase in depth. So we have seen the reason for that, right? The walls of the dams are specially thickened and broadened at the base than at the top. This is done to withstand the huge pressure of water. Now, we will see a small activity to understand this characteristic. Near the topmost layer, make a little hole at the side. You will see that the water flows out from the hole like this. It does not roll along the walls, it flows at an angle. Now, let's make a second hole near the layer under it. You will see that the water flows out at a wider angle as compared to the earlier case. We continue to make holes in the walls and we will notice that the water literally squirts out. This proves that the pressure at the bottom is more than the pressure at the topmost layer. How do the molecules behave in liquid state? The molecules are constantly moving in a liquid state. While they are moving, they collide with each other. The molecules also collide with the walls of the container, right? To every collision, these molecules exert thrust on the walls of the container, thus exerting the pressure on the walls of the container. So, what is the second characteristic? Liquid exerts pressure on the sides of the container. So, to prove this, you need a metallic tube with a small opening near the base. Tie a rubber balloon to the side opening. Now, gradually pour water into the tube. You will observe that the balloon starts bulging as you go on increasing the amount of water. What is the reason for bulging of the balloon? This bulging is due to the fact that liquid applies pressure on the side walls also. Hence, we conclude that liquid applies a lateral pressure at the walls of the container. The lateral pressure is exerted by the liquids and the gases, but not by solids. Now, we will explore the third characteristics. What is that? Liquid pressure remains the same in all directions at a given depth. Yes, we are going to see a third activity to learn about this. Take a water bottle, make holes at the same horizontal level. Fill the bottle with water. Observe that water gushes out with the same pressure in all directions. What does it prove? This proves that liquid pressure remains the same in all directions at a given depth. So what is the fourth characteristics? Liquid pressure depends on the density of liquids. To show this, we are doing an activity. We are going to take identical open glass tubes A and B. Tie a balloon to each of the tubes at one end and leave the other end free. Balloons tied to the two tubes must be of the same size. Now, pour water into the tube A and equal volume of kerosene in the tube B. Notice the bulge in the membrane in both the cases. You will observe that bigger bulge is produced in tube A in which water is filled. What is the reason for the formation of a bigger bulging? The bigger bulging is due to the fact that water is heavier than kerosene because water has higher density than kerosene. This proved that liquid pressure depends on the density of liquids. So, what is the fourth characteristic we have learnt? Liquid pressure depends upon the density of liquids. Now we will move on to the fifth characteristic. A liquid seeks its own level. To show this, we are again going to do an activity. This is the fifth activity for learning the characteristics. We take tubes of various shapes which are connected to a horizontal pipe. Fill water in any one of the tubes. It will be observed that from the tube in which you are pouring the water will move to the horizontal pipe and then to other tubes connected to it. The water stands at the same height in all the tubes irrespective of the shape of the vessel. So, this activity showed that liquid seeks its own level. So, what are the characteristics we have learned? Pressure increases with increase in depth. Liquid exerts pressure on the sides of the container. Liquid pressure remains the same in all directions at a given depth. Liquid pressure depends on density of liquids. Liquid seeks its own level. So far, we have learned how the liquids exert pressure. So, does the air exert pressure? Yes, we are surrounded by air and the air exerts pressure on us. The envelope of air which surrounds us is known as atmosphere, and we call the pressure as atmospheric pressure. Now we will see a small interesting activity to prove that air exerts pressure.
Take a plastic bottle filled with water. Take a cardboard paper and place it on the open end of the bottle like this. Hold this paper with your hand so that it does not move from its position and invert the bottle. Now let go of the paper. What did you see? The cardboard paper sticks to the surface. Why is it held to the surface? It is held to the surface because of the air pressure that is pushing the paper in the upward direction. The upward air pressure is sufficient to counter the downward push exerted by the water. Now make few holes in the bottle at its base. What happens now? Why did the paper fall off? Did the upward pressure on it stop acting, or did it reduce in the value? No, it didn't. The upward pressure on it by the air remains the same, but the downward pressure increased in its value. When we made holes in the bottle, we allowed air to flow inside it from the top. The air from the top started exerting pressure on the water. The combined pressure of water and air from top could easily overcome the pressure exerted by air from the bottom. Hence, there is net force acting on the paper in the downward direction. That is, there is more pressure in the downward direction. That is the reason why this paper gets detached from the surface.
We have witnessed the strength of the atmospheric pressure. There are 5 layers in the atmosphere. They are troposphere, stratosphere, mesosphere, thermosphere and exosphere. Already we have learnt in liquid pressure that liquid pressure increases with depth. Why? Because the bottom layer of the water holds the weight of the top layer of the water. Similarly, here also pressure in troposphere is higher than the pressure experienced in the other layers. Therefore, the pressure decreases with the height. Pressure decreases with the height. Now, shall we learn the definition of atmospheric pressure? Because we have witnessed how important the atmospheric pressure is. The thrust acting on unit area on the Earth's surface and on all the objects on Earth's surface is called atmospheric pressure. Can you imagine how much will be the value of atmospheric pressure? It's 1 lakh pascals. It's equivalent to placing 2 elephants on top of our head. But why don't we get crushed by air pressure? Because it's very huge in amount. The air inside of our lungs is at the same pressure as the air outside. So it presses our chest cavity outward with almost same force as it is being pressed inward. So this helps in counteracting the atmospheric pressure. Also, the blood pressure balances the atmospheric pressure. So in our body there are so many mechanisms which helps in balancing the atmospheric pressure. Now we will see an interesting experiment called crushing can experiment to witness the science of pressure.
Do you know that air can crush things? You do not believe me? Let me show you.
Take some boiling water and pour it into a plastic bottle using a funnel. Do not fill it completely, just a little less than half the bottle. Cap it tightly. Now pour cold water over the bottle and watch it get crushed. What happened here? When the boiling hot water was poured into the bottle, the steam pushed some of the air out. At the same time, the air above the water surface was heated and hence expanded. This also pushed some of the air out, and the amount of air inside the bottle reduced. Then when we capped the bottle, the air could not enter back in. Finally, when we poured cold water over the bottle, the steam condensed to water and the air cooled and contracted. This led to lowering of air pressure inside the bottle. as the air pressure inside the bottle fell significantly below the pressure exerted by the air on the outside, the walls crashed in.
Air in the pneumatic tires in our bicycle or cars exert pressure on the walls of the tires from inside. This introduces cushioning effect and thus absorbs the shocks generated due to rough texture of the road. Ride a bicycle up a slope using a tire filled with air and ride up the same slope without air in the tires. Can you feel the difference? That is the difference made by the air pressure.
Now we are going to see some important effects of the atmospheric pressure. Have you ever used the fountain pen? How you should suck up the ink into the fountain pen? You have to apply the pressure, right? When you are applying the pressure, the ink will get into the fountain pen. It's also due to the atmospheric pressure. And have you ever seen a syringe? How the hospital people like nurses and doctors use the syringe? They will push the piston. They will pull or push the piston. When they are pulling the piston, the liquid is rising in a syringe, and it's also due to the atmospheric pressure. Lizards are able to walk on the wall and stay whenever they feel like due to the suction pad like function of their feet, and it's also because of the atmospheric pressure. Have you ever used the straw? How you should use the straw? You will suck up air when you are using the straw, right? When you are sucking up air, after some time what will happen? The liquid will come in. So how this works? When you suck a straw, you swallow some of the air from the straw. This makes the pressure of the air inside the straw less than the pressure of the air outside. So the outside air pushes the cold drink into the straw. Because there is a pressure difference, the pressure will flow from high pressure area to the low pressure area. So the outside air pushes the cold ring to the straw. So that's how the straw works. Nose bleeding at higher altitudes. Do you know how the pressure will be at higher altitudes? We have already studied that pressure decreases with increase in height, right? So the atmospheric pressure is low at higher altitudes, but the pressure inside our body does not change. So here also there is a pressure difference. The pressure inside your body does not change, but the pressure outside is very low, right? So there's a pressure inside the body which is much higher than the atmospheric pressure, causes the bursting of arteries which are closer to the inner skin of nose. So what is this? These are the picture of astronauts and mountain climbers. So what is the special thing you are noticing in them? They have wear the special outfits. Why they have wore this kind of outfits? To protect them from the low pressure, to protect them from the adverse effect of the low pressure, because we know at higher altitudes the pressure is very low. So they have to wear such kind of outfits to protect them from the low pressure. Astronauts have actually to go beyond the limit of the atmosphere. There, the pressure on their bodies would become negligible. This makes it necessary for astronauts to put on special type of outfits. So, what are the effects of atmospheric pressure we have seen? The working of an ink pillar or fountain pen to suck up the ink. How the lizards are able to move on the wall because of their suction pad, and how the syringe works, and why we are getting the nose bleeding at higher altitudes, and how the straw works based on the pressure difference, and how the astronauts and mountain climbers are using the special type of outfits. Why they are using? To protect them from the adverse effects of the low pressure. So these are the important effects of atmospheric pressure. Now we will solve some problems on pressure. The first question is, a solid weighs 80 Newton. When placed on a surface, the area of contact is found to be 1.6 square meter. Find the pressure exerted by the solid on a surface. So what is the given things? They have given the weight. Weight is equal to force. So that is 80 Newton. And they have also given the area of contact. So when we know the force and when we know the area, it is very easy to find out the pressure, because pressure is equal to force divided by area. So 80 Newton divided by 1.6 meter square, which is equal to 15 Newton per meter square. And we can write the SI unit of pressure as Pascal, so 50 Pascal. So this is how you should do this problem. Just take out the given things and substitute it in the formula. So this problem is very easy one. Now we will move on to the next one. A rectangular wooden piece weighs 25 Newton. If it is placed in such a way that it is 25 centimeter length and 10 centimeter width, or in contact with the surface, what will be the pressure exerted by it on the surface? So they have given the weight and they have also given the length and the width. To know the area, what we should do? We should find out the area using the length and the width. And notice that the parameters of length and width are given in centimeters. So you should be careful in converting that also. So now we will go on to the solution. So the solution is, you have to take out and write the force is equal to weight is equal to 25 Newton, length 0.25 meter. We have converted the centimeters to meters. 25 centimeters is equal to 0.25 meters. How did we got this? We divided the 25 by 100, because 1 centimeter is equal to 1 by 100 meter, or 1 meter is equal to 100 centimeters. So we should do the conversion and write the answer. Width is equal to 10 centimeters. So 10 divided by 100, it is 0.1 meter. And we have to find out the area. Area is equal to length into width, and we are multiplying and finding out the area, 0.025 meter square. And we have to substitute it in the formula. So 25 Newton divided by 0.025 meter square, and we are getting the answer as 1000 Newton per meter square. And the SI unit of pressure is Pascal, so we can write it as Pascal, 1000 Pascal. So this problem involves the conversion of units and also the finding out of the area using the length and the width. The assignment questions for this week are: it's difficult to insert the blunt nail on wooden surface. Reason out. Define turning effect of force. Give its SI unit. A solid weighs 120 Newton. When placed on a surface, the area of contact is found to be 3 square meters. Find the force exerted by the solid on the surface. List out the characteristics of liquid pressure. Describe an experiment to prove that air exerts pressure. Write any two effects of atmospheric pressure. So the first two questions are from the lecture conducted on Zoom. They are very easy question, and the last 4 questions have been discussed in this video lecture. So do submit the assignments through the GCR and take care of yourself. Make sure to do the interesting activities and projects which are being posted on the GCR. So making boat and some other activities posted will be very interesting. So do submit your assignments, activities and projects. See you in the next class. Take care of yourself. Bye bye.